Well, so my apology is I'm sorry, I'm having a bumpy start to the semester, and so I'm answering you all way too late. And it's not your problem, it's my problem if I answer you late. So when those things, if you're emailing me about a problem, we will solve it. I'm not gonna hold to due dates if it's my fault, okay? And if you ask me for help with Pearson's and you can't get any further in your Pearson's course, I'm gonna wait until I answer you and then I'll reopen that assignment for you. So I don't want you to stress because of my busyness. So I'm gonna go over 3 of the questions from the last unit. And the reason I remembered to record it is because I really want you guys to know it's in the syllabus, but you can retake any of the exams. So in order to retake an exam, within 3 days of you taking the exam, email me. I will give you a PDF of your original exam. You will email me back just a work shown page with all of the wrong answers corrected. And then when I get that email from you, I will reopen the exam for like a week. And then you'll email me back when I'm to input your new grade. Okay, so you can always retake an exam. And if you have to ask me for a question and it takes me a long time to answer, I apologize, number one, and I will make sure that it doesn't affect your grade that I'm answering slowly. 1 second. Oh, you guys are so nice. My last school they were really nice too. But Oklahoma, you guys are so nice. Okay, let's get started. Or turn off my video, either one. All right. So one of the questions that was sent to me is 3 plus 2 times the quantity x minus y, and this is inside of absolute value bars, right? So they want to know the absolute value of x minus y, and then you need to multiply it by 2 and then add it with 3. Out of the 4 examples I have to go over with you, 3 of them are about the order of operations. Okay, so it's just important that in the first unit we get the order of operations down. So 3 plus 2 times absolute value of x minus y over x plus 2y. The order of operations is parentheses or grouping symbols. E is for exponents. And then MD or DM, it doesn't matter. So multiply or divide, and then add or subtract as the last thing you do, okay? So on the exam, people were, here for example, you were adding -6 and +3, and then you were multiplying it with -6 and +2. Instead, I want you to combine these. So the first thing you would do would be the most inside parentheses. So first we're doing P. There are no E for exponents, but M comes before A or S. Okay, so it looks like we want to go left to right and add these because they're inside parentheses, but this is inside parentheses, so this we do first, and then we multiply before we add or combine. Okay. So that was the order of operations. P stands for groups. When you have a division bar, that means everything in the numerator is a group and everything in the denominator is a group. So you want to solve this and just put it over whatever you get for this bottom one. So that was 3 plus 2 times the absolute value of y is -2 and x is 9. So -2 minus 9. And I told you I put parentheses around them and then I didn't put parentheses around them. Over 9 plus 2 times y, which is -2. Good. So that's how I would rewrite that to begin with. Equals. So the grouping symbols are parentheses, division bars, absolute value symbols, and radicals as well. So I'm going to do what's inside the absolute value symbol first. So that'll be 3 plus 2. This is implied times, right? -2 minus 9 is going to be absolute value of -11, because if I just add 9 and 2 and keep the sign, it becomes -11. Down here, I can combine these because they're so independent, right? So 9 plus 2 times -2, we want to multiply before we add. So 2 times -2 becomes -4. Sorry, I couldn't decide whether I was writing a 9 or a 4. So now we have 3 plus 2 times the absolute value of -11. When you're taking -11 out, it becomes +11, right? So now we have 3 plus 2 times 11 over 9 minus 4. Since that's all that's left to do, I can just call that 5. Here I have multiply and I have add. So I need to multiply before I add. So that becomes 3 plus 22 over 5. 22 plus 3 is 25 over 5, which is 25 divided by 5, which is 5. Good. So I know we're going over stuff that you have already obviously been graded on, but this is in case you want to retake the exam or in case things like this continue to come up in our future units. Good. So we replaced -2, -9. We solved inside this because this was a grouping symbol. Then we took it out, made it positive because it's a distance. We multiplied before we added. Here we just multiplied before we added. Now we combined, right, or subtracted. 3 plus 2 times 11 becomes 3 plus 22, which is 25 over 5, which is 5. And then we got the absolute value of -3. They were asking me, why is it still negative? Because you're only looking at what is inside these bars, okay? So this is still just 3. So we lose the absolute value bar by making it a +3, just like we lost the absolute value bar by making it 11, but you still have this negative to bring over. Good. I think there was also a question about why my answers were, or a couple people had like on the exam, they chose the answer. They chose this answer, but the correct answer was ... and that was the only difference. The ... means it's going in that pattern or in that pattern of adding 1 each time forever.
She
Okay.
can hear me.
So unless it ends, yeah.
This isn't like the actual questions on the exam.
It isn't, it looks different, or it is the questions on the exam. Sorry, I'm just trying to clear things up very quickly. Was that? This was not from the exam. This was not from the exam. These two are questions from the exam, yes. But I felt like I didn't teach them well enough at first. So when you see something like this and it doesn't end at +7, and you want the list to go on forever, you need the ... But what you needed here on the quiz was to define integer or whole number or real number. So that's kind of how you decided. All right, this one, 25 minus . So I guess if you retook it, you could encounter this exact question. I remember my work, but you don't. I think it scrambles it each time. All right. So here, start with grouping symbols, right? Because we have groups, then exponents, then multiplying, then adding. So groups would be, did I copy it right? 4 minus 6 becomes -2. And then we're taking that to the third power. Something to note, if you're taking it to the third power, it can be negative. Remember, if it's to the second power, it's negative, never negative. It's always positive. But if you're multiplying it 3 times, it's always negative. So it's actually a -8. Is that right? Then we have 25 minus 8 minus 6 minus 11. I would just subtract 11 minus 6 is 5, right? Close the parentheses. Carry the addition. Now I have 25 minus 8 minus 5 is 3 plus -8 or -8. So now I need to subtract. Okay, I'm not multiplying 25 times 3. I'm 25 subtracting 3 from 25. Sorry. So 25 minus 3 is 22, plus -8 or minus 8. 22 minus 8 is 14. So just remember to do the group or the parentheses before the exponent, the parentheses, and then you're subtracting it, and then do the bigger parentheses, keep subtracting it. Would 6 minus 11? Yes, it's a -5. Thank you. Well, that's good. So if this is an exam question, I even got it wrong. 8 minus -5 is 8 plus 5, so that's 13. That's convenient. 25 minus 13. 12 minus 8 is what, 4? Thank you. All right. Last one. 6 is being multiplied by the quantity -6 plus 3. This is where it got people. Times the quantity -6 plus 2. I think that was the end. Good. And also you can interrupt me with questions like how this happened, anything like that. Again, you're starting with parentheses. You have 2 sets of parentheses. So all of this and the little one start with the most innermost parenthesis. -6 plus 2 is -4. That's being multiplied by 3. And then all of that is being multiplied by 6. Don't add these first because we need to multiply before we add. Good. And guys, we have a lot of review days in this course, so feel free to interrupt me. It's okay if we start going slower than the lecture schedule. So if you have any questions about the exam questions, but still didn't make sense, you thought it was unfair, I didn't teach it, something like that, let me know. So don't add, first multiply. 3 times -4 is -12, I think, right? We're still combining that with -6 and multiplying all of that by 6. Now we're going to add before we multiply because of the parentheses. -6 minus 12 is -18. Multiplying that by 6, -18 times 6, I get -108. Oh. Yes. So just make sure that you're following this order: grouping, exponents, multiplying, dividing, adding, and subtracting. They are long. There are 2 very long ones on the exam. All right. Anything else from the exam or from the quizzes? All right. So 2.1, we are going to solve linear equations by combining like terms, and they will only be in one variable. So it won't be 3x minus y equals 3 times x plus 1, okay? We will use examples with fractions and decimals, and that some equations will have no solution, some will have infinite solution, okay? Linear equations. An equation is a statement that 2 expressions in which 2 expressions have equal value. Solving algebraic equations in one variable involves finding a value for the variable. So when we say variable, we usually just mean x or some other letter. So it involves finding a value for the variable that makes the equation true. Clear grouping symbols and fractions use opposite operations. So when we're talking about operations, we just mean multiply, divide, add, subtract. The opposite of this would be this, right? So those are inverses of each other. The opposite of add is subtract. The opposite of multiply is divide. To isolate the variable on one side by undoing addition or subtraction first, then multiplication or division. So before we read this part, we were just talking about PEMDAS, or you can call it whichever one you like, GEDMAS. Grouping symbols, exponents, multiplication and division are on the same level. So it does not, you just go left to right. I was going to say it doesn't matter, but it does matter. Go left to right on multiplication and division and go left to right on addition or subtraction. They're equals, okay? Parentheses are grouping symbols, exponents, multiplication, division, addition, subtraction. But because we are solving it, we are working backwards. We're doing the opposite thing. So first is addition and subtraction. Then multiplication and division comes second. Sorry, I'm very bad at keeping this in the frame. Okay. Then, just like we've been practicing with our fractions, anything done to one side of an equal sign must be done to the other side. So if I had 3 equals, let's say 30 is 15 and 15. Okay. And I just wanted to, I know I'm not solving anything. I just wanted to divide 30 by 5. 30 divided by 5 is what? 6? Is 6 equal to 15 plus 15? It is not, right? But if I take that 15, divide it by 5, and that 15 and divide it by 5, then I have 6 is 15 divided by 5 is 3. 15 divided by 5 is 3. So 6 is 3 plus 3. That is why you have to maintain equality by ensuring that anything you do to one part of the equation, you do to every other term in the equation. If it's adding though, you're just 10 is 8 plus 2. So I want to subtract. No, that's a foolish thing to subtract. Subtract 3. I'm not going to subtract 3 from 8 and from 2. I'm just taking away 3 from everything. So it would probably be better. 7 is 7, right? So it would probably be better to write this as 1, 15 plus 15 divided by 5. So I'm only doing it one time per side, just to be clear. 15 divided by 5 is 3. 15 divided by 5 is 3. So if I subtract 3 over here, I subtract 3 from the whole thing over here. Linear equation just means if I was to graph it, it would make a line. So again, we're just doing the inverse or opposite. X minus 4 is 7. So I want X alone over here with just an equal sign here. That's what I want. So I see that it currently has a 4 and it's being subtracted. What is the opposite of minus 4? I'm going to add 4 so that the 4 disappears. So over here, I have to add 4. X is 7 plus 4 is 11. X is 11. Good. And you can line up the 7 and the 4 because they're like terms. 7 plus 4 is 11. When you have decimals, it's very important to line up your terms. And you're always welcome to use a calculator for this. If you're taking it in the Academic Resource Center, the Academic Resource Center has calculators for you if you do not have one. So decimals, what you want to do to subtract or combine decimals is line up the decimal point. So I have negative 3.2 and I have negative 6.6 and I'm combining them, or I'm subtracting 6.6 from 3.2, right? So 2 minus 6. I mean, are we doing this by hand? Are we subtracting? 2 minus 6. I have to carry the 3, right? Or no, I'm adding them because it's a negative. Negative and a negative, so it's like I'm adding them. 3.2, 6.6. 6 plus 2 is 8. 3 plus 6 is 9. They were both negative, so it's a negative 9.8. So that's my first step. Or you can just throw it into your calculator. Negative 3.2 minus 6.6, negative 9.8. If I just simplified that, because those were like terms, negative 1.2 equals negative 9.8. So it's y minus 1.2 equals negative 9.8. Now I want to get rid of the negative 1.2, so I have y alone. So I'm going to do the opposite of subtracting, which is adding. So now I just have y on this side. Negative 9.8 plus 1.2. Negative 8.6. If you were going to do that by hand, you can't subtract 1.2 from 9.8. So yeah, you can just do it like that. You can leave it lined up, but your sign is going to be negative, okay? Don't put a positive below the negative. Yeah. And keep the sign negative. Good? Questions? So anytime you have a negative number and a positive number and you're combining them, you're subtracting, okay? You always, if you're subtracting by hand, you always need to take the greater number. So ignore the signs. The greater number here is 9, put it on top. 9.8, sorry, 1.2, and subtract them. Good. And then because that was a negative, this becomes a negative. However, if you put 1.2 and you subtract 9.8 and you're just doing it by hand, you will not get negative 8.6. So make sure if you're doing it by hand, you're choosing the bigger integers on top. Yes, I can slow down. Sorry. Do you want me to redo any of them? Or give you another example? I can give you a second example with the decimals. Yes, there's plenty of time in this course for me to slow down. I just go too fast. All right, I'm going to give you another decimal example. All right. This will definitely be in my math lab. 0.2x minus 4. Good. Equals, do you want to make it like this or easy? 3.8. Good. All right. So, oh, I don't like that one. That one is very different from that one. Let me rewrite this. Negative 4x plus 0.2 equals 3.8. Good. Apologies. Now I have x. I'm combining x with a decimal, and it's going to equal 3.8. Okay. Here it's being added 0.2. Right? Here it was being subtracted, so I need to do the opposite, add it, okay? Here it's being added, I'm going to do the opposite, I'm going to subtract it, negative 0.2. Again, we line up our decimals, so negative 0.2, okay? Negative 0.2 is the same as, so 0.2 is the same as 0.2. Negative 0.2 is the same as negative 0.2. Okay, so feel free to write a 0 there if you want. Good. The 3.8 is bigger than the 0.2, so it goes on top, and we're subtracting because the signs are different. This is a positive sign, this is a negative sign. So 8 minus 2, 6. 3 minus 0, 3. Okay, it was a positive 3.8, so it's a positive 3.6. Sorry, I of course made this into a multi-step problem. Negative 4x equals 3.6. Now I need to divide by negative 4. So I showed you how to add or subtract by hand, but I really wouldn't, that's gonna like create a lot of time, and you already have so many, right? We already have like 37 of these problems, so make sure you do have a calculator. Here I need to take the 3.6 and divide it by negative 4. If your calculator doesn't have a negative, that's okay, because 3.6 divided by 4 and 3.6 divided by negative 4 are going to give you the same number. You just have to decide whether it's a negative or positive, okay? If I'm taking a positive, dividing it by a negative, my answer is always going to be negative. A positive divided by a positive, my answer is always going to be positive. A negative divided by a positive, my answer is always going to be negative. A negative divided by a negative, my answer is always going to be positive. And same for multiplication, okay? So if your calculator doesn't have a negative sign for dividing, that's okay. You just have to know what sign to give it. So negative 4x plus 0.2 equals 3.8. Negative becomes negative 4x equals 3.6. I take that 3.6, I divide it by the negative 4. I take the negative 4x, I divide it by negative 4, and I get x is whatever your calculator says when you divide those. Negative 0.9. Or negative 0.9. Okay. Now I'm going to give you this one. We're going to do this one, and then I'll come back and do one that's like this but has decimals. The secret with decimals is just lining up the decimal point, and then the real difficulty with this example I gave you was deciding how to subtract that if you're not putting it in your calculator. Okay. And if you want, also, you guys, if there's something that I'm saying that you don't know how to do, like I don't know how to combine these two, just say, can you make me a video on how to combine numbers, how to combine decimals, how to subtract negatives, how to subtract positives from negatives, okay? And I will do that, and I will put it up, and other people will be able to see it and thank you, even though they won't know it's you who asked for it. Question? All right, so here, if we look at this, 6x plus 8 minus 5x is 8 minus 3. I am going to combine terms that are the same only if they're on the same side, okay? So I have this side of the equal sign, and I have this side of the equal sign. The 6x and the negative 5x are the same term, or they are like terms, sorry. To be the same, they'd have to be 6x and 6x. They are like terms, and they are on the same side of the equal sign. 8 minus 3, same terms, so like terms, same side of the equal sign. 8 minus 3 is 5, right? Tell me when I get this wrong. That positive 8x, sorry, no x, the positive 8 just comes straight down. 6x minus 5x, it's just 6 minus 5. 6 minus 5 is just x. Good. So first we combined like terms. But not across the equal sign, okay? Combine like terms on each side, I should say. Now what can we do? Now it looks a little bit like this one, right? So now I need to do you can call it the inverse or the opposite of each operation until x is alone. Okay, so I combined 6x and negative 5x, I got x, plus 8 equals 5. So the inverse of adding 8 to something is subtracting 8 from that same thing. So if I do it on this side, I have to do it on this side. I can line up the 5 minus 8 because they are like terms. So I can either say 5 minus 8 is negative 3, or if I don't have a calculator, sorry, this is so scattered. I have 5 and I have minus 8. 5 minus 8. I can't just do it like that. It won't work, right? What I do is I think without the signs, which number is a higher number? The 8 is. So the 8 is first, the 5 is second. I'm still going to subtract them. I get 3, okay? Which is what I got here, but here I got a negative 3 because the 8 is the bigger number. So the sign of the answer is the sign of the bigger number. So when you need to subtract negative 9.8 and positive 1.2, I need to combine them. They're different signs. I cannot do this. I need to look at 9.8 and 1.2 without the negative sign. I need to decide that 9.8 is the biggest number. And then I need to subtract the smaller number. I get, when I subtract 9.8 minus 1.2, I get a positive 8.6. And then because my bigger number was negative, I give the 8.6 a negative. Okay. So when I have 5 and negative 8 and I need to combine them, I can't do it like this. I put 8 on the top, I put 5 on the bottom, I subtract, and because the 8 is negative, the answer becomes negative, sorry. Because the 8 is negative, the answer gets a negative sign. So that's how to combine two numbers with different signs. If they have the same sign, you're just adding them and using that sign, right? If it was negative 8 minus 5, you're just adding 8 and 5 is 13, but it's a negative 13. If it is negative 10 and 4, I need to put the 10 on the top, subtract the 4. So 10 minus 4 is 6, but the 10 is negative, so the 6 becomes negative. Okay. Or use a calculator. So negative 8 and 5 combined to get negative 3. 8 minus 8 is 0, so I just have x is negative 3. Good. Okay. You can also put the negative 3 back into the equation to make sure that that is a true equation. So we had 6x plus 8 minus 5x is 8 minus 3. And we decided that x is negative 3. So now I have 6 times negative 3 plus 8 minus 5, again, times negative 3 equals 8 minus 3. And so if you have this as your question and you have x is negative 3, x is negative 2, x is negative 1 as your answer choices, you can just put in each of those and see which one gives you a true statement. The statement's going to be true if the number on this side is equal to 5, right? Is equal to 8 minus 3. So 8 minus 3 is 5. So is 6 times negative 3 plus 8 minus 5 times negative 3 equal to 5. It is. So you can check any answer that way. All right, I told you I'd do one of these and then I would do a decimal example of that. My decimal example will be 0.2 again. So 0.2x, this is the one I originally wanted to do, plus 0.3 equals 0.9x minus 1.8. Okay? So if they are decimals, I want to combine like terms on each side. There are no like terms on each side, right? So now I need to combine like terms by moving things, by doing the inverse. So that equal sign is a wall. I need the x to still be alone on one side of the wall in the end, okay? So I'm just going to take everything that doesn't have an x and move it. We're adding 0.3, so I'm going to subtract 0.3. I put it below the negative 1.8 because those are like terms. Here, this cancels. I have 0.2x equals 0.9x. Again, these are both negatives, so you can just add them. 8 plus 3 is 11. Carry the 1, so we have 2.1, but remember they were both negative, so minus 2.1. Is that okay? All right, so I made that one go over here, but now I have an x on this side. I only want constants on this side, and I want all my variables over here. So now I'm going to take the 0.9x and move it over here. Here it is a positive number, right? Positive 0.9x. So to get the inverse of that, to get rid of it, I need to subtract. Good. So that's nothing. That's negative 2.1. 0.2 minus 0.9. Again, these are different terms. These were the same, so we added them. These are different, so we need to decide which one's bigger. 0.9 is bigger or 0.2 is bigger? Bigger. 0.9 is bigger than 0.2, right? So I subtract. 9 minus 2 is what, 7? But the 0.9 is negative, so it's a negative 0.7. Bring over the x. So 0.2x minus 0.9x is 0.7x equal to negative 2.1. Good. All right. Now I have x. I want it to be alone, but it's not alone. It's only 0.7 of an x, or the x is being multiplied by 0.7, negative 0.7. How do I get rid of something being multiplied by negative 0.7? I divide by negative 0.7, divide by negative 0.7. Yes. Thanks. Cancels, I am left with only x, because if it's the same number on the same term on the top and the bottom, and it's being multiplied by the other terms, I can cancel them out. Again, here it's just very useful to have a calculator. So we have negative 2.1 divided by negative 0.7. I get 3. It's okay if you get a decimal. Don't think you did it wrong just because you get a decimal sometimes. Okay, that was a very difficult one. But that's how we're going to work with variables on both, or sorry, variables on both sides of the equal sign and decimals. All right. And I know we're not getting through these notes very fast. No, it's just, this is hard, but it's hard because we don't use, like when we're using decimals in our lives, right? It's just like if you were doing this every day of your life, this would be very easy. So if you're feeling discouraged, it's just because this is a completely out of left field thing to be studying, in my opinion. Like it isn't in terms of math, but it is in terms of your life, I think. As a math teacher, I love it, but I don't think that you should feel like you're not smart if you don't get this, because as you can see, I make tons of mistakes and it's my job to get this and to like look at it every day and do it every day. I still make lots of mistakes. So again, combine like terms on each side. 4p minus 11 minus p. We're just combining 4p minus 1p, right? 4 minus 1 is 3. Here I combine the 2 and the 20. 2 minus 20 is the same as 20 minus 2. But because the 20 is has a negative sign, it's negative 18 plus 2p. So just like we did with those decimals, now we are moving everything that is not p over here and anything that is p over here. Now I have 3p equals negative 18, sorry, plus 11. I didn't really finish that thought. Good. Adding 11 because we were subtracting 11, so the opposite of adding is opposite of subtracting is adding. Negative 18 plus 11, again, we're going to subtract. Negative 18 plus 11 is the same as 18 minus 11. 8 minus 1 is 7. 1 minus 1 is 0, but the 18 is negative, so it's a negative 7 plus 2p. Good. Now I want the 2p over here. It's a positive, so to move it, to get it over here, I need to do the opposite of adding 2p, which is a minus 2p. Good, so I still have negative 7 over here. 3p minus 2p is just p. Good. Okay. 3 times 3x minus 5 equals 10x. Here, it wouldn't be wrong to distribute the 3 times the 3 and the 3 times the negative 5, but the faster thing to do is it faster? Yeah. The faster thing to do, if there wasn't an x over here, it would definitely be faster. But anyway, the faster thing to do when you need to multiply something, no, it's not. Let's do it this way. Let's do it the long way. 3 times 3x is 9x. 3 times a negative 5 is a negative 15, no x. So I distributed the 3. I was debating because you can divide by 3, but making this into a fraction does not make our lives easier, does it? All right, I already have 9x here, a negative 15, and a 10x here. If you want, you can just move the 9x over here. Math teachers like the letters to be on the left side, but because this is the bigger x and that all of the constants are already over here, I think it makes sense to just move the 9x, be faster about it. So now we still have negative 15 equals 10 minus 9 is x. You would get the same answer. So same problem. You would get the same answer, by moving the 15 over. So I'll add 15. So now that's 9x equals 10x plus 15. Good. And then I'm going to move the 10x over here by subtracting 10x, subtracting 10x. 9x minus 10x is just a negative x equals a positive 15. Always do that. I want that negative x to be a positive x, right? So I divide it or I multiply it by -1. Anything I do to this side, I have to do to this side. Negative number divided by a negative number makes that number a positive. And then anything divided by 1 is itself. 15 divided by -1 makes the 15 a negative 15. So there are two ways to get x equals negative 15. All right, I know we didn't get very far at all on this, and that is okay. I will extend out your due dates, okay? So we'll just go through this unit a little bit slower. We can try to do the last example. 3 times y plus 3, because then you can get further on the homework, over 5 equals 2y plus 6. Good? All right. So here you have this entire quantity being divided by 5. The due dates on Pearson's will be your real due dates. So if you never go into Blackboard, but check Pearson's for all of your due dates. But what was the actual question? No, as soon as I change it, there will be a new due date. And those are the ones you follow. And email me if you're confused, definitely, because I am. All right, 3 times y plus 3 divided by 5. If I want to get rid of a fraction, I multiply that fraction by the denominator of the fraction. If I do it to this side, I have to do it to this side. Good. So that cancels that out. It becomes 3 times y plus 3 equals, now I'm going to take that 5 and I'm going to distribute it to the 2y. 2y times 5 becomes 10y. And then 6 times 5 becomes 30. Good. We have 1 minute left. All right, now I'm going to distribute that 3. 3 times y plus 9 is 10y plus 30. So now we are back to something we already have practiced doing. Just going to move the 9 over, move the 10 over. Remember, you have to do the opposite. So it has to be minus 9 and minus 10y. But you can do it all at once if you would like. So 30 minus 9 is 21, still positive. That cancels. That cancels. 3 minus 10y, 7. Negative 7y. Divide by, I know I'm rushing. Divide by -7, divide by -7. Y is -3. All right, sorry guys, you can go. Have a wonderful day. Email me with questions. I super apologize for my late replies.